Right, 10.2 is on series, and a series is the sum of a certain number of terms in a sequence. So to determine that, you say which one you're starting with and which one you're ending with. And you have this sigma symbol, which is the Greek letter sigma, and it represents the sum. Um, and capital S is also used to represent sum. So again, this is an index. That I stands for index. Sometimes other letters are used instead of I, but these should match up. And so you're starting with this value, plugging in 1, and then you go to the next integer 2, then the next integer 3, continuing on until you get to whatever this number is. So I'd go all the way till the I being 4, and then I'd stop. So it's about starting input and ending input. Sometimes people mistake it for the number of terms you're going to go to. It sometimes matches up with that. In this case, it does, because 1 to 4 is 4 terms, but it's really about the input being 1, 2, 3, and 4. Here it would be 2 to 5 as the input. So again, not 5 terms, the input being 5 as the last input. You actually see here 4 terms. So when you find this, you're finding the sum, the sigma, the sum of these terms. And so each term is calculated by plugging in the term number you're on. So plugging in 1, and plugging in 2, 3, and 4 for the I. And it is a sequence, and arithmetic. You keep adding 5 each time, as you can see here. And so you can also find the first one and then add 5 until you get down to, this is plugging 1, 2, 3, and plugging in 4. And then just add them together. What you might notice if you do a couple of these is, get down, is that the first and the last, and then the second and the second to last, and the third to last, etc., have the same sum. And so basically you can pair them up, working your way from top and bottom downward, and they will have the same value. Because of that, we have a pattern that allows us to come up with a formula to describe that pattern. So you can see here, this one was 29 and 29. This one is 17 and 17. And so we have 2 17s. It give us 34. And it's not always 2. This one I just stopped with 4 terms. That's why there's 2 of these and 2 of those. But we will generalize it in a minute. So here we're starting with 3 for both my i's. To add fractions, you need a common denominator. You can also use your calculator and put parentheses around these terms. You can reduce this if you'd like, but your calculator doesn't need you to reduce it in order for it to find it. It'll sometimes give you it in mixed or in improper format, and just depending on your calculator and its settings. But that is the sum of the terms starting with 3 and ending with 5 as your input. Here, that's an I there, so we plug in your index value here and there. So I put, in this case, 3 there and there, then 4, then 5, then 6, and then 7. We stop when the I is 7. The reason we don't want to simplify on this one is just that to get a common denominator would mean basically need another x minus 1 to the 4th power to make them all 7th, here to the 3rd, 2nd, 1st power. And if I do this to the 4th power, I'd have x minus 1 times x minus 1 times x minus 1 times x minus 1 times x minus 3 in the numerator, and it's just a lot of multiplication, and it gets to be a very large numerator. It's not worth the time. The idea is that you understand your input and that you're adding. So I hope that helps with 10.2. Essentially, you just need to know the mechanism for this. So again, it is that the sigma means sum, and this is your starting input. That's your ending input for your variable, your input value here. And I hope that helps. Have a good day.